Today we're going to be making a table saw stand for this DeWalt table saw. So I have an existing workbench and I need this saw to go in the front of this bench and be level with this tabletop. This project had to start off with a list of constraints based on the workspace I had to work with and the end functionality I wanted it to have. Having a table saw stand that was permanently built into the workbench was not an option, as my existing workbench was already quite large and I wanted to have the flexibility of being able to move it around and fold the table saw stand into it when it was not in use. With these constraints, I began designing. I began making some rough sketches on paper, and when I thought I had an idea that would work, I took it over to SketchUp to get a more accurate model. I didn't go into extreme detail in SketchUp, skipping things like hinges and screws, but I got an accurate model of the joinery, which was going to be the main challenge of this project. Constraints. It had to be 25 inches in length when folded, 32 inches in length when fully extended, adjustable in height from both the front and back, able to support at least 40 pounds plus large stock that I would be cutting. Ideally, this thing should be able to support somewhere like 300 or 400 pounds. Legs that fold up into the saw and don't get in the way of the casters on the workbench. It needs to be rigid, able to accept dust collection hose in the back, and it can't jeopardize the structural integrity of the existing workbench. It's very unlikely that you will be building this exact table for your workspace, as I feel I had a very specific list of constraints and requirements I needed. However, I do think this design for a sliding dovetail joint would be very useful for many applications, especially where a very strong sliding mechanism is required without the usual play that's inherent into most mechanisms that slide. I hope you find this method for creating a sliding dovetail useful, as I have not yet seen a video that uses this exact same method. Feel free to leave your thoughts in the comments. Thank you for watching. This is the sliding dovetail joint that I'm going to be making, and you can see here that this is a stop joint. So to begin, I'm going to cut 4 strips of maple at 3 1/4 inches. And I want the final width to be somewhere around 3 inches, so I'm giving myself an extra quarter to account for the saw curve. So before running this piece through the table saw, I took a look at this edge, and this board's been sitting for a little while, and the factory edge isn't super clean, so I'm just going to true it up with the hand plane. I'm going to rip 3 1/4 inch strips. Once I'm finished making the initial cuts on the table saw, I should have something that looks like this. 2 pieces that are 3/4 inches and then 4 of these thinner pieces. For the thinner pieces, I decided to resaw them on the table saw, as I tried to do it on my bandsaw and actually broke my blade since I was using a thin blade and not a resaw blade. And I decided to do multiple passes just because I was getting a lot of binding on the blade from the wood releasing pressure. And I actually didn't go all the way through this cut just because it seemed a little bit dangerous to do it. So I opted to leave a little thin strip and just resawed it with my handsaw. Now, one thing to take note is maple is a little bit of a harder wood to work with. It's prone to tear out if you're planing against the grain, or there's some grain that you actually can't even plane. But what I tend to do is just set the blade real shallow and make sure that your tools are super sharp. I'm going to be making the sliding dovetail portion of the bracket that extends, and to mark this out I'm going to do it really simply without even doing any measurements. I'm just going to be using the marking gauge and a sliding bevel. So to establish the side that's shortest, I'm going to take my marking gauge and draw a line. Now I've already figured these dimensions out ahead of time, so I'm just tracing what I already have. So I'm going to line my sliding bevel with the marking gauge line I made and just do a knife line. Next, I'm going to come to the table saw, and I don't have a digital angle finder, but I'm just going to use my sliding bevel and lay it flat on the table and then rotate my blade to match that angle exactly. And then once everything's in place, I'll just lock it down, and now I have that angle set perfectly. After making the cuts on the table saw, I should have something that looks like this. You can see that there's two dovetail portions and then portions that are going to be making up the part of the bracket that slides. Table saw left quite a few burn marks, so rather than hitting this sandpaper, I'm actually just going to take the hand plane, and that's going to give me a crisper edge. For me, this is the perfect example where a hand plane is the perfect tool for the job. If I had 50 of these pieces or even 10, setting up a joiner would make a lot of sense, but for the two pieces that I had to do, the hand plane is quick, it's accurate, and it leaves me with a perfect crisp edge. So here I'm laying out where I'm going to be making my cuts, because the sliding dovetail portion is not going to be this entire bracket, and I needed to cut it up into 3 different pieces. I'm going to be gluing up this dovetail and dovetail housing just as you see it, with the small top piece like so. The reason I'm doing this is because there's going to be a slot routed in here, and this is going to allow me to retract the table and not have this be a part of the sliding mechanism. So only 1/2 of this sliding dovetail is actually going to be moving. Okay, so in order to speed up this glue up process and to make it a little bit more accurate, I'm going to use a little trick. I'm going to add CA glue on the outside with activator, and that way this piece is going to be able to set up immediately, and then I'll use this as a reference for my actual dovetail piece and the second piece that holds it. That's just going to prevent everything from sliding around. So I'm going to add CA glue on the perimeter and wood glue in the center, and this is just going to prevent any unnecessary squeeze out. I'm going to spray activator on my piece here. And this sets up almost immediately, so it's important to get it as accurate as you can get it. And then I'm going to use my patented glue brush to remove any glue. So here I'm just cutting off the excess, because I cut these boards to 3 1/4 inches, and in total width they ended up being about 3 inches because of the saw curve on the dovetail portion that I had to cut out. So this was the trickiest part of the build, and I spent some time thinking about it, and I actually overthought it. So what I initially tried to do was space this part that basically hugs that dovetail piece with tape. And I thought that this would give me just enough clearance to make this joint tight, but not too tight. And I was also really worried about actually just gluing everything together and then not being able to take it apart. The first bracket I tried like this, and then the next one
I actually didn't use any tape to space it. I just used light clamping pressure and glue just on the parts that I wanted glue, and I really tried to be super careful. I also oiled the part of the joint that I didn't want getting glued together, and that actually ended up working a lot better than the version that you're seeing here. Now, chances are you're probably not going to be building a table saw stand like this, but I think this method for making a sliding dovetail is really great, and I think there's a lot of different uses that you could potentially use for this. I've seen designs where people cut out the whole dovetail portion on the table saw, just hogging out material with the blade, but I feel like this method really gets you a really tight fit if you want a joint with no play in it. So where you see it highlighted in red is the only place I put glue, and again, I was super careful not to get glue anywhere that could potentially glue the joint together, because that would just be a disaster and I would have to remake the whole entire bracket over again. So here I'm gluing up the final piece on the sliding dovetail. This is going to be the piece that has a slot running through it. And I'm just using some masking tape to align the pieces, and then some clamps to put some pressure on it. All in all, I was really happy with how these came out, and this was definitely the hard part of the build. I spent a lot of time thinking about it, and I think I would definitely choose the second method where I don't use tape to space it and just use some light clamping pressure. After I finished gluing up the sliding dovetails, I proceeded to cut more strips on the table saw for what was going to be the legs. For the legs, I glued up 2 strips together that were 1.5 inches by 1.5 inches, and I got myself a nice square leg that was going to be sturdy without any kind of wobble. Here I'm marking the piece that is going to mount onto the aprons of the workbench, and I'm just doing one giant dovetail that I'm cutting in this piece of scrap 2x6, which I later cut into the table and mount it. Generally, when I'm marking anything that requires precision and accuracy, I like to use a knife wall because that ensures that I get the most accurate cut. Whereas a pencil line, it's very easy to go to the right or the left, but a knife wall is a lot easier to follow. Next, I'm going to install the dovetail slot onto the workbench. So I just flip this on its side, and I'll cut these with a handsaw. So this is the part of the project that I was really not looking forward to. I debated for a while whether I was going to take off the aprons and try to mount this, or if I was going to turn the table on its side back and forth and just do it like this. I ended up just cutting it like you see me cutting it here, and I'm not sure if it was less work, but at the time it seemed like that was going to be less work than disassembling the table, taking off the apron, and cutting the dovetail into it. One of the aprons was also pretty badly warped because when I had made this workbench, the wood I was using was pretty green and had moved quite a bit since I initially put it together. So one of the slots you can see leaning in toward the table, and I wasn't really in the mood to try to fix it completely. I may do so in the future, but for now, that's how it's going to be. So here I'm marking out the legs. I'm going to cut basically a big slot in the middle of this, and that's going to allow it to sit so it doesn't have any play for back and forth. I'm using the combination of a marking gauge and a square to do this. I make the initial cuts with a hand saw. I cut out most of the waste with a coping saw, and then I finish it up and pare it down with a chisel. So I needed to cut some recesses for the hinges because the circular part, as you can see, would stick up out of the wood and it would prevent those pieces from sitting perfectly flat with each other. So I marked out the spacing on my hinges and then used a router to cut that recess. So I feel like the hardest habit to get into when I first started woodworking was to sharpen often and to make sure that my tools were actually super sharp every time I worked with them. Here I'm just showing how easy it is to stop in the middle of working, hit the hand plane on a 1200 grit stone, a stropping block, and then you have a really nice tool that's sharp and tuned to work with. So here are the sliding dovetails all glued up, and I have a nice piston fit for both of them so they slide very firmly. There's no play. The next step is to route the slot that is going to go so that the table can lift up into the workbench and be stowed away when it's not in use. So I did a combination of hand planing and sanding to get those little mounting dovetail slot thingies to sit flush with the apron. It was actually quite awkward to plane at this angle. I got a bit of a workout, ended up doing some of it with the chisel. But after struggling with this for quite a while, it was all finished and there was only one problem. I had not made the slot big enough so that the tabletop would actually retract into the bench completely, so I had to set up the router and make the slot longer. I was actually really excited to be at this step because now I finally get to put the whole thing together, and so now I'm routing a slot to where the cross beams are going to sit. I was too lazy to do a mortise and tenon joint, so I just took the router and made one big slot right down the side. Here I'm cutting the cross beam that is going to hold the tabletop together and give it side support, and I cut part of it on the bandsaw and then finished it with the handsaw. I pared this down with the chisel, and then I split this on the table saw so that I could use one piece in the back and then one piece in the middle. Here is the front of the dovetail housing. I'm going to route a slot into it, and I did it on the table saw, just doing multiple passes since I don't have a dado blade. So the glue up went smoothly. I used a combination of clamps and those little right angle clamps to keep everything aligned. After it all came together, the joint still slid, so I was happy. So I ordered some of those little M8 plastic knobs, but I felt like they didn't give me quite enough closing power like I wanted, so I cut out some oval knobs on the bandsaw out of some scrap walnut that I had, and then drilled out the rough shape of the knob and chiseled out the final shape. So then I went to the belt sander and rounded off the edges and took away any of the saw marks, and then finished up the rest of the sanding just by hand. So I finished the knobs, and now I needed to cut all the slats for the tabletop, and I basically did this with what's a sliding crosscut sled for a router that's upside down. So at this point I needed to attach those slats to that top piece that you see screwed in, but so that they would still slide on that middle piece. So I needed to screw them in there and into the front. And then the smaller slats I would be screwing into one of the support pieces in the back, and then also one right in the middle. So here I'm just laying everything out, and I'll be attaching it from the underside with screws. I marked the hinges and where I would attach them to the underside of the table, and then I also routed a new slot for the wellboard on my workbench so that I could move it to the up position when I was using the table saw. And while I was at it, I decided to flatten my workbench because, well, why not? If I was going through all the trouble to make a table saw stand, I at least wanted to have a flat outfeed table. So I did so with the hand plane. So I gave everything a good sanding, and then I covered it with a generous amount of paste wax. And my preferred method for applying the paste wax is to take a large glob and then pinch it in the rag so that it squeezes out from the middle. And then I rub down every single joint and moving piece on the table to make sure that it slides easily and doesn't get stuck. I probably made everything fit a little bit too tight, as the table was quite hard to pull out at first. But one of the main things I wanted for this table is so that it would have no play, so I think I would rather still be tight than loose. Once I added the adjustable leg lifts, then I was ready to put the tabletop together. It was a bit tight coming together, but once I got it on, everything worked just as planned. It slid back and forth with no play and was quite sturdy, so I was happy about that and ready to try it out.